Give a few minutes here. It's only 2 minutes till the hour.
Yep. All right.
How many people are you expecting on the call?
I'd say like more than 10,
Great.
like 15, something like that.
Wonderful. That's great.
Yep. Yeah, basically for us it's evening, which for us it's evening, which means our clients from the US, they are mostly from the US, they're waking up and we have to collaborate with them, and it's
Mhm.
somewhat challenging to make sure that the majority of people join the call, but we have the recording, so no worries, people will.
Yeah.
So
I have the same challenge. A few of my team partners are in Germany, Romania, Switzerland. And so I usually have to get up quite early in the morning, and they stay late in order to collaborate with the US.
yep.
So it can be, most of my mornings start at 7 or 7:30, which is it's a little early, but it's okay because they're staying later.
All right. So let us give our guys a minute or two to join, and we'll start.
I can talk for a minute about the presentation before everyone gets here. This is something that I'm very passionate about as a coach and a teacher for engineers, developers, QA, whoever is involved in developing products or just developing software to build products. It's a skill that I see lacking in most software developers. And I did not have this skill when I graduated with a computer science degree and started working with IBM as a consultant and as a software programmer. And it was a more senior engineer who taught me how to debug. When I started to use the skills that I learned, I began to be able to solve problems much more quickly. And that was a great asset, not only to my organizations, but to my career. And when I would sit down with someone who would working on a bug or a problem for an hour, hour and a half, 2 hours, sometimes days, they just couldn't get it. When we would sit down together and I would go through this process, we almost always would solve it within about an hour. Now, maybe the solution didn't get to production for quite a while because sometimes it takes a long time to move product to production, but at least we would have the patch in place and the code ready for production very quickly, simply by executing a series of skills and steps. And so I began to teach this to people, whoever would want to learn. So I've given this presentation a few times within my company and outside of it, and it evolves over time. And as we'll see in the presentation, this is tailored for about an hour, maybe a little less. There are areas we could go into deep depth about, and so I think in the future I'm going to modify or add another presentation that really gets into details, the hands-on example of using these skills. So this is like debugging 100, and I want to create another, which is debugging 200, which will be really inside of a very complicated open source piece of software. How do you find a major problem in a code base you are not familiar with, and possibly even a language you are not familiar with, using the skill? And I just did this. Yeah, it's a great, and I just did this at work. My team, we're not really Java programmers particularly, and we've been tasked with developing a proof of concept using a Java open source software stack. And there was a bug, and nobody could figure it out. So I went in with one of my co-workers, and we applied what we'll see today. And we found it in, I don't know, 15 minutes, not even 15 minutes. We found it almost immediately. Testing took a long time, but finding it and solving the problem was very quick. So, okay.
All right, guys. So I propose we start. Basically, the majority of people is already here. So, guys, please welcome Jason, our speaker. He's one of the technical leads at Adobe. Okay. You didn't misheard Adobe. Yes, that's correct.
Adobe, that's right.
Yeah. I hope you remember Jason's speech last year. it was in June. It was about FinOps, and this time I'd like to welcome Jason here with his new topic for us, which is all about debugging, which is a bit wider topic for us, and I believe interesting and applicable. So without further ado, over to you, Jason.
Thank you very much, Valerie. Good morning.
Hi, Jason. Can I just take
Oh,
a
let's
word
see.
for
Oh, my
10
goodness.
seconds, please? Also.
Sure, please.
Yeah. Thank you, Jason. Yeah, good to see you this morning. Thank you for finding time to spend some time with our team this morning. I know that it's early morning on your side. So we are happy to see you. We are thankful you find this time. And on behalf of the whole team, I want to say just thank you. We know Jason with Jason each other like for a couple of years. We have different relationships, and when we talked about it, Jason kindly agreed to spend some time and share some of his experience with us. So, Jason, thank you for that. And yeah, now it's your turn.
Thank you, Alexei. I'm sorry I didn't see you on the call. I beg your pardon for interrupting. Thank you for the warm introduction.
I'm here.
Appreciate it.
I'm here.
I am in a technical lead position at Adobe. I'm here today in an unofficial capacity. So you can see there's no branding on this document. This is something I've been teaching for 10 years or so on and off. So I did bring this into Adobe, but essentially this is a presentation that I do independently. The craft of debugging. You'll notice on the internet that you see a lot of the art of debugging. You'll see people talk about how it's an art. And that bothers me. I am in my regular life also a musician and an artist in the sense of I create music of art of music, excuse me. And music, like any other what we call art, is based in technique. You want to learn to play the piano. If anybody here is a musician, you know, you sit down and you learn the technique. You learn how to move your fingers. You learn the scales. You learn music theory. Guitar, same thing. If you're a painter, you learn the technique of painting. Everything is based in a set of skills and techniques. Art is a nice term for sort of the general, but really you're talking about a craft. And as you get better at your craft, woodworking, plumbing, right? Now we're outside of art. We're into skill sets of being able to construct something and build something. The word art starts to become less and less meaningful, when really what we want to talk about is a craft. You learn the skills, you develop the skills over time, you get better and better at it. You start as an apprentice, then maybe you're a journeyman, and eventually you become a master at it and you can teach other people. Whoops, excuse me, wrong window, there we go. So what we're going to talk about today are a few things. One is debugging is a craft, not an art. And I'm going to talk about this. I'm going to probably talk very much about the skills and the craftsmanship of debugging and get the idea of art out of our heads. I'm going to talk about the technique. If it's a craft, what are the skills? What's the technique? What tools do you need? So the technique we call the rule of 3 and 3. It's not the only way to debug. There are lots of other ways. It's just one that I'm choosing today. It's the first technique that I learned, and I consistently go back to it. Maybe it's because I'm very familiar with it, maybe because it works, doesn't matter. So I'm going to start there, and in your professional lives, if you discover other techniques to debugging, that's fantastic. I hope you do bring them into your skill set and teach your peers other ways besides what I'm going to talk about today. The other part of debugging is actually a broader concept of problem solving, because debugging is really a subset of problem solving. We have a problem, we need to solve it. It's what we're getting paid for. Time is not always on our side. And so one of the skill sets under problem solving, and problem solving is a very wide topic. I'm just going to talk about one technique within the realm of problem solving, and that is dividing the problem domain. What does that mean? We'll see when we get there. And then we tools, right? If you're a master carpenter, you can have all the technique in the world, but if you don't have your tools with you, you're sort of stuck. Same thing with debugging. So what are 3 different tools that we can use for debugging? These are the fundamental tools. These are the most basic tools that we have available to us. And no matter where we go, we will have access to at least 2 of these tools, if not all 3. And then finally, if we have time, I'll go through a live, very short Python interactive debugging example for us to go through. When we get there, we'll see if I can get that set up for us. Okay. Oops, I need to go. Okay, craft, not art. Let's talk about what debugging isn't. It is not some innate talent that some people have and others don't. I see this in organizations. They always say, oh, go talk to Bill in the corner. He's a genius. He's really strange. No one talks to him, but he can figure this out in a minute. Guys, maybe he's just, has figured out a way to debug more quickly. Maybe he is really smarter than everybody else in the room, but that's nonsense. It's just, it's not scalable. It's nonsense. Debugging is not some a priori knowledge. We're not born with this prior to our existence, right? It's not something we know without skills and training. Now, there is an argument to be made for there's always some great musician who's born and is an immediate prodigy like Mozart. Okay, look, forget about those people. They're not us. What debugging is a skill. You learn it and you refine it over time with training and repetition, just like anything else we do in the world that we learn. Some of us learn more quickly than others. It doesn't matter. It's not a competition. The only person we're competing with is ourselves of yesterday. So how quickly do we as individuals learn something? And it's a skill. And the skill is informed. In other words, the skill is developed by the techniques that you learn and you practice over time with a specific set of tools. If this sounds familiar to you, that's because this applies to almost any artisanship or craftsmanship that is known to man. So debugging is no different. Why is it important? A recent article in Forbes website talks about how AI co-pilots in software development have increased workloads. Now, they're not supposed to do that. They're supposed to make our lives easier. But employees are reporting increased workloads, higher expectations from the C-suite, more frustrations, and a gap between developer knowledge and with the output of these co-pilots and AI assistants. In other words, the AI assistants are creating source code blocks that the software developers do not understand. It is very important for the skill sets of developers to be able to maintain the expertise and velocity of learning that we were able to do before co-pilots. We can't depend on co-pilots to do our work for us. It's a co-pilot. It's not a pilot. It's an assistant with us, which means we still need to maintain our skills. One of the skills we need to maintain even more so than before, it is more important to learn debugging now and be more efficient at it because co-pilots create source code without the overall business context. Even if you have the greatest prompt in the world, the AI co-pilots are not yet developed enough to understand the product requirements or the overall context of the requirements for your software. And sometimes it hallucinates and creates code that doesn't work. It's just, it's nonsense. It's broken. Therefore, debugging is now a key. If it was a key before, it's really a key now to efficient implementation of AI into work streams. If you're going to introduce AI into a work stream, you really need to know how to debug the output of the AI, right? It's a skill that is more important than ever in development environments that are AI assisted. So let me talk for a minute about this right here. What do I mean without context? A program manager or a product manager may come to his development team and say, we need to launch a new customer service portal in the cloud, and we have a budget of $50,000 per year. And that's everything, not including our salaries, but that's the cost of the cloud, that's the cost of continuous integration, et cetera. Even if you plug that into your prompt, or if you plug efficient code into your prompt, your code is not, the AI assistant is not going to be able to develop source code that meets the contextual requirements of our entire environment. We need to keep cloud costs down. it's going to create source code that may actually require very large EC2 instances in Amazon or very large VMs in Azure. That gets very expensive. I'm going to blow my $50,000 budget. Products are going to come back to engineering and say, what the heck are you doing? You can't, this is not feasible, right? Our return on investment is now negative. Our cost of goods sold is now way above budget, right? The COO is going to go crazy. Yes, but the AI created it for me. It must be correct. We need to make sure that we, as co-pilots, it's our responsibility to go through the code produced by AI and make sure it is contextual for the requirements of the company, and we understand what it's produced. And if it's not working as expected, this debugging skill is going to be more and more important to us. Any questions so far before we get into the techniques of debugging? I can stay on this screen for a minute. And raise a hand or, okay, fantastic.
Let's move forward, yeah.
So let's talk about technique a little bit. Debugging, craft, what's the technique? 3 questions and 3 tools. Let's talk about 3 questions first. I will ask myself these things. What do I want the code to do? And I'll either write it down or I'll talk to somebody about it. We want the code to do whatever it is. What is the code actually doing? It's broken. It's throwing an exception. It's reporting the wrong emailing address for a customer. It's not shipping to the right physical location, whatever it is. How do I know it's doing it? Well, someone's complaining about it. I have a bug ticket. But really, how do I know that the code is actually doing that and not maybe somebody in the shipping department is confused? Or maybe it's a UI error. So this last question, how do I know the code is doing what the code is doing, is where our tools come into place. I need a magnifying glass to see what the heck's going on. So the 3 tools I'm going to use to figure out, to answer this third question, how do I know it's doing it? And what is the code doing and how do I know it's doing it? The tools I'm going to use to answer those questions are print statements, which is the easiest. That's the first thing we learn in programming school. Logging, which is a little more complicated, and the interactive debugger. In my experience, less than 1% of developers that I know use the interactive debugger or know how to use the interactive debugger. This is in the world of Python, Java, C++. Little less C++ because a lot of C++ developers depend on the interactive debugger. It also generally doesn't apply to iPhone and Android user programmers because their debugger is built into the IDE and it's a critical part of it. There's really no excuse for Python and Java programmers not to be able to use the interactive debugger. So I'm going to talk about that once we get to that phase in this presentation. So 3 questions, 3 tools. That's the technique of 3 and 3. Now let's drill down into these into this craft and start talking about really the tools and how to get there. But first, before we can start using these tools, we need to know how to solve problems. So let's take a detour here and talk about problem solving, because these tools and these questions aren't going to be as valuable to us if we don't know a good technique for solving a problem. We've heard the expression, how do you climb Mount Everest? 1 step at a time. A slightly less politically correct expression is, how do you eat an elephant? And the answer is 1 bite at a time. Haha. Oops. I have some code in here that looks like it's in black. I apologize for that, but I can't seem to get to it. That's fine. So the entire domain, we say divide the problem domain. What's the domain? Let's define the word domain. The entire domain is the entire system you're analyzing. Great, programmer, developer. You've just been told you have to analyze the entire system. Now, in some of your customers, and certainly at Adobe, these systems can be enormous. And it is very daunting, if not impossible, to analyze the entire system. It's just too big. There's not a chance you can do it. So what's the answer? Climb Mount Everest, break up the domain into smaller, easier to analyze segments. Easy to analyze segments would be the ideal. You want each section of the entire giant system broken down and start to analyze it in smaller pieces. You can't analyze the whole Earth, but we can break it down into, start in your backyard if you need to. Start in your county, break it down. Very important. That's the very first thing we need to do. When I'm working with somebody, whether it's Adobe or as a consultant, and we're working on a problem or we're developing a product, first thing out of my mouth is divide the problem domain. Break it down. What are we building? Can't build an entire system in one go. Break it down, work on one piece at a time. You do want to work quickly, I get it, but again, break it down into smaller, easier to understand and operate pieces. Here's an example domain breakdown. At the very top, we have pieces of a program, the UI request signature and data to the backend API request handler. There's maybe a lower level function. It could be a database abstraction layer or a data object layer, etc., all the way down. So in the case where a UI requests data from a backend API, the whole domain is the entire system. The UI, everything, bang, that's the whole world. As I've said, divide the problem domain. I'm going to divide it into these top level. I'm going to divide it into the UI. I'm going to divide it into the UI request signature and data. Then the backend API request handler, and then I'm going to divide again, lower, and just keep dividing until I run out of things to divide upon. Within each of these sections, I'm going to divide even further. So let's look at the UI. There's not much to divide there, I suppose. Next one, I divided the UI into its request signature and the request data. So if I was going to debug and analyze this little make-believe system, I'd start with the UI request signature and data. Why? Just that's a good place to start. Arbitrary. I can start anywhere in this. But for the purpose of today's discussion, I'm just going to say, Jason's decision, I'm going to start with UI request signature and data. There's no right way to start, as long as you start somewhere in this divided domain. Over time, you will be able to develop the skills and then instincts. Instinct is just the development of skills to the point where the knowledge becomes somewhat subconscious, to figure out where a good place to start is. So just put that out there. Why am I starting here? It's a good place to start. That's the only reason. I'm going to look at the request signature. Is it correct? I'm going to look at the request data. Is the request data what I'm expecting? And it gets sent to the API request handler on the back end. Is the handler's request signature equal to the request signature being sent to the front UI? Let's divide again. What about the request data? Is it valid for the API request handler? Good question. Let's look at the next step. Request algorithm. Is the algorithm to process the data from the front end correct? Well, that's a good question. So I'm dividing. I'm just going through each of these steps. When you first start out as a debugging, this can seem tedious and it can take time. The more you practice, just like guitar, piano, art, plumbing, carpentry, motorcycle riding, the more you do it, the better you get and the quicker you can operate, right? So I'm just going to keep dividing. These are all the different things I'm going to think about as I divide the system into easier to understand and easier to analyze pieces. Trying to figure out the problem from this top layer is not going to be as straightforward as looking at, hey, let's look at the response data. Is my API responding to the front end correctly? Good question. The answer is yes in all these. I'll keep going down. Go to the next layer. Divide. Keep breaking it up. Here's an entire domain. Again, simple flow chart. We have a database on the left side. We have a bunch of processes. We have a sub-process. We have another process before it gets to the users, all the way on the right. This is a nice little top-level example. This could be microservices. This could be sub-processes. This could be systems. This could be anything. The important thing is that there's a database. There's a center of processing, another center of processing. These arrows are data being sent back and forth, ingress and egress, probably over a NAT gateway or a load balancer, et cetera, et cetera, et cetera. So we get a bug, an exception, and we can say it's a try catch or it's a bug. There's a problem, there's a hard halt, and it's raised in this process. We have to fix it. The cause of the exception can be in any component in this entire system. Remember, the entire system is the entire domain. The cause of the exception can be in anywhere in this entire domain. Well, that feels daunting. I don't know where to start. This is crazy. Well, we know the exception is raised right here, right? We want to divide the problem domain into smaller pieces. Let's start with this process. You don't have to start here. I tend to start here and kind of do a dictionary sort or a binary, sort of, or binary search, excuse me, and dividing the pieces left and right. You could start at the database side. You could start at the user side. Whatever you're comfortable with. It's generally my practice personally to start where the exception is so I can take a look at the exception and be able to figure out what is the exception, what's the stack trace telling me, what's the debugging logging or the error logging telling me, get as much information at the scene of the crime as possible. I can tell you what I'm not going to do is go look at Stack Overflow right now or look at Copilot. We're making a huge assumption that Stack Overflow points me to the correct information, that the person writing that post actually knew what they were doing. Sometimes that's correct. More often it is not. We also don't necessarily know that Copilot understands the context of what we're doing. There are, of course, exceptions to that rule, but generally speaking, I'm not going to start searching the web for solutions yet. I don't even understand what the problem is yet. If I don't understand the problem, I'm not going to understand the answer. So the first thing I want to do is get my little bug magnifying glass out. These are my tools, print statements, logging, and interactive debuggers. And I want to understand the problem. That's what I really need to find out. So what's going on? So I will divide, and I'll start here, and I'll start using my 3 tools to look at what's going on. Nothing, I can't find it. Let's go to the next section. Let's take a look at what's going on in there using our tools. Is the data being sent correctly over, are the API signatures correct? Is the data being sent correct? Are the algorithms correct? Again, dividing it down based on what I saw on the previous slide where I had all those little subdivisions on that section. You know what I'm talking about, this piece? In each of those little blocks, go through these steps or even more steps. Keep breaking it down, looking at the different pieces of what's going on. Keep dividing. Another part of the whole domain is the flow of data and the request and response signatures. It is a separate component of my problem domain. So you want to debug the data flow as well as the functions. It's easy to get caught up in these rectangular process blocks, right? But we can't forget these, I've made them in yellow against this black background. We can't forget data transfer. The data itself, the methods of transfer, the signatures of the data transfer, do they agree, et cetera, et cetera. So don't forget to divide data flow as a separate subdomain of our overall problem. And keep looking. So here's a non-programming example. This is a bash command. This is actually something I ran into with a team where an engineer spent 4 days trying to figure this out. What was happening is they were running this bash script and it was coming back with a -1. That's it, -1. And so the first thing this engineer did is they went to Stack Overflow and said, oh, you have to do this magical configuration option. Well, wait a minute, we don't even understand what the problem is yet. So how would we approach this, taking everything we've talked about so far in problem solving? Can someone volunteer to tell me what's the first step you would take if you were given this bash script, being told it's bombing, it's returning a -1, it's not working? What's going on? Any volunteers? Nobody? Okay. Dimitro.
Go ahead.
I would probably break it down into like separate commands.
Yep.
Right.
Execute them one at a time, right?
Yep.
Exactly.
Maybe start with some suspicious.
Yeah. You could start with spaces. You could execute each of these individually on a command line in a terminal. Just go step by step. Pretend you're the execution process and run them one at a time. Yeah, exactly. Now, if that seems elementary to you, congratulations. The interesting thing is when I give this conversation. Oh, I don't know if you could see. Were you able to see me drawing on the screen?
Oh, not really.
Oh,
Yep.
shoot.
Uh,
Did-
f- 2 minutes ago, yes, but now you're not drawing.
Okay, got it. Interesting how that works. Okay, cool. What's interesting is that almost whenever I give this talk, somebody always gets the right answer, just like that. In real life, when I'm sitting down and I am asked to assist an engineer or a team in solving a problem, they don't do it. They go to Stack Overflow. They look at this and they freeze. They go into analysis paralysis. They don't know what to do. The first thing I did is exactly what you described, Dimitro. I would go, I'd open a terminal and I'd run, I'd run this command, right? Change
Now you're
directory.
drawing. Now we can
Great,
see it.
thank you. Good, thank you for the confirmation there. So I'll run change directory, and then the next line I'll run the CURL. The next line I'll run my configure, and I'll wait. And when I did this in real life, of course, where it was all fine until I hit this make install command, where it bombed with a -1. And it bombed because it did not have authority to the directory that the make install was being told to assemble the code in. So the problem was not what Stack Overflow said. Stack Overflow said you needed this fancy flag inside this configuration script. The problem was my local environment did not have the set of authority for the mode of the particular target directory. So the problem was in this make install. Sorry, Stack Overflow, it was not a good solution. But by breaking up the problem domain into its individual pieces, we were able to solve the problem. So I hope that was super elementary. If it wasn't, don't worry. After this, you'll have a better set of skills of how to start looking at something and breaking it down. Okay, next slide. 3 tools. So we've talked about dividing the problem domain. That problem solving, the first step in solving any problem is break down the problem into smaller pieces that are easier to execute upon and easier to understand. Any questions about that so far? Any comments? Anyone would like to add anything?
Yeah, guys,
Cool.
feel free to ask your questions. You can either raise your hand or just ask. You can type your questions in the chat. You can type it in Russian or Ukrainian. I will translate. And basically, you don't have to wait. Once you
Yeah.
have a question, just shoot.
My Ukrainian is limited to being yelled at by my great-grandmother, so you'll have to translate for me.
Okay.
Yeah.
Well, you're one of us, actually.
Yeah. Who hasn't been yelled at by their great-grandmother? Okay, 3 tools. Print statements, logging, and the interactive debugger. This is the tool set, right? Specifically for debugging. Now, there are more tools, obviously, your IDE, et cetera, et cetera, et cetera. So you can use whatever additional tools you like. What I highly encourage is start with these 3. Add on more tools as you start to investigate and solve problems. That's excellent. Share your solutions with your peers. Teaching other people some of these skills is a great way to learn. When you teach something, you are also teaching yourself. And so the more you learn about this stuff, grab one of your coworkers or grab somebody and walk them through it. Even if they already know it, it's a really good tool to cement this knowledge into your head. Print statement. I think we're all familiar with, if you're a programmer, you're familiar with a print statement. In general, this is one of the first things we learn as we're learning programming. You're printing to standard out or standard error while the software is running. It's a quick way to examine state without interrupting operations. Usually the first thing we learn as developers, but it's not the only tool in the toolbox. What I see as I'm working with people is at least 80, if not at least 80% of the time, if not more, larger percent of the time, it's the only tool programmers use to figure out what's going on in a program. More experienced, more advanced engineers and developers use other tools. And it's important to have all the available tools that you can possibly use to more quickly solve a problem. When do you use a print statement? Well, when you need a quick snapshot of a piece of data or state of a workflow, and you don't need a lot of context about what's going on. You know, in other words, you can look at the software, get an idea what the context is, but you don't need a huge, contextual understanding of where you are in the process at this point. You do it when a debugger isn't available. Sometimes you don't have access to an interactive debugger. You're sort of stuck. Dealing with microservices and you don't have permission to log into the remote system. You're dealing with remote threading or coroutines and you don't have access to the actual coroutine. You can't interrupt the coroutine because it's being handled in an event layer. Things like that. Or when logging is overkill. We'll talk about logging in a minute, but sometimes logging is just a fire hose of data and information, and we just don't need that much. So there are great times to use a print statement. What I want to emphasize, it's not the only tool in the toolbox. It's a very powerful tool. By all means, use it, but use it as a sibling to these other two tools. Logging. What is logging? You're writing data, arbitrarily formatted data. The data can look any way you want, to a log file or to a database. You can output it to a screen as well, but that's very challenging to go through hundreds of thousands of rows of data on your terminal screen. So generally, you want to write the data to a file or to a database. You want to collect a lot. Processing information, data that's being processed, state of objects and state of data, state of the process, state of the system, right? State is there's so many states across, in an EC2 instance, you have the state of the container if you're in Kubernetes, state of the node, state of the NAT gateway, state of the overall compute instance that you're hosted on, etc. It's fantastic for providing data for analysis and other tools. You can use this in Grafana. You can use this in Splunk. You can use this data in Excel spreadsheets. You can use it in any other tool. So it's a great way to provide source data for further analysis elsewhere. Common use is to log the timings of functions and methods and services within a large system and analyze those timings broken down by process to figure out where you might be lagging or where you may have a problem. Things like that. Profiling. You can use logging to do profiling of an application for performance and expense. How long is it taking to do something? You'll see this more and more in machine learning. Profiling, machine learning, modeling, because modeling, training a model is becoming extremely expensive. Inference is becoming extremely expensive as you grow users. So one inference, one user, not so bad. Millions of users, now you're talking real money, and you want performance to be very high. Logging is a great way to analyze performance of an inference engine. When do you use it? Well, use it when you need to collect a lot of different kinds of information about what's going on. You also use it when you need to collect data that's useful in other analytical applications, Excel, Grafana, and I will caution, this requires some planning. So log with scale in mind. It is very easy to create logs that are hundreds of terabytes in size, hundreds of gigabytes in size, or terabytes in size. You can easily run 10, 20, 100 terabytes of data just in one log of one process on larger systems. Larger systems, Adobe, Universal Music, you get the idea. Large systems. User log levels. If you're not familiar with log levels, I would suggest read the documentation. There are different levels of logging that you can gate. There's informational, there's debug logging, warnings, and critical errors. They all have different kinds of information in them that you're going to want to get into. It's also really valuable when you need to analyze the contiguous change in the state of objects. In other words, you just need to see a time series of state changes of objects in your system. Make sense? This is a really good in-between sort of tool between debugging and printing. Printing is very static. Debugging will stop the process at a particular point in time. In this case, logging can get you a whole stream of information about the contiguous step-by-step change in the state of objects over time. Super valuable, depending on what you're looking for. Let's talk about some logging documentation. And I added this slide because as I was teaching this course, I was meeting engineers who didn't know anything about logging. I used Python because I code 60% of my time in Python. I work in a group in Adobe that is very Python heavy. However, this idea applies to Java, C++, Rust, Golang, whatever you're working in, Ruby. Go to the documentation, look up information about logging. In this case, I stole a screen from the documentation. I have a link to the documentation in Python. It'll teach you everything you need to know about logging in Python. Super, super valuable. In Python, if you understand Python, that's great. If you don't, this is importing the logging package. That's just a straight import. Going to create an instance of a logger. Whoop, there we go. I'm going to configure the logger. I'm going to give it a file name. I'm going to tell it to output in UTF-8 encoding, and I want to log debug and above. So I'm going to ignore info. I'm going to log debugs, warnings, and criticals. I think this is incorrect. If I'm setting logging level to debug, oh no, that's correct. Because I'm specifically telling the logger to write an information line. You know what? I caught myself. I'm not sure if this is correct or not. If I'm saying the logging level to debug here, I'm not so positive that this information is going to get sent to the file. I'll have to look that up. But anyway, I didn't catch that before. Interesting. This is anyway an idea of how to a little bit more understanding of what logging is and a pointer to the documentation. If you've never used logging, go read the documentation. It's a great tool, very important tool. What is the debugger? Well, it's a tool to interrupt processing and will provide a REPL, an interactive terminal, with which to examine the stack, examine individual stack frames, objects, variables, constants, other data. So it's a way to stop processing at a particular point of time, preserve state of the operation, and investigate. It's like surgery is a little bit of an extreme example, but it's a bit like freezing time and analyzing what's happening in a running process. It's extremely powerful, and with practice, using debuggers can reduce your debugging time by orders of magnitude. Why do I say that? I tell a story. I was working at a startup, and we hired a software engineer who had a master's of computer science. And I expected him to I would have thought he would have understood this. He did not. And he was tasked with fixing a bug in the product. And he stared at it for over an hour and a half. And he couldn't figure it out. And I looked at him and said, "Do you need help?" He said, "Yes." And we sat down and we went through these steps to divide the problem domain. The first tool I used was an interactive debugger at the point of the exception. So at the point of the problem, I said breakpoint. We looked at this. We looked at the data. We looked at all the state. We just basically investigated what was happening at the point of the exception. And in about 10 minutes, we found the problem. The problem was some malformed data in an iterable data structure. What that means is there was a list of data and that list was malformed. It wasn't formed properly somewhere up the stack towards the UI. So we found in 10 minutes what he was unable to find in over an hour. By using these tools, we were able to really, really get to find problems and identify and solve these problems much more quickly than we would otherwise. What happens if an interactive debugger is not available to me? As I mentioned, maybe the job is running in a coroutine or in a thread or in a virtual thread. Maybe it's on a remote system I don't have access to. I can push code to the system, but I can't SSH in and interrupt processing. There are lots of times when this doesn't apply. Now, ideally, if I'm a software developer, I want to be able to run everything in a Docker container on my local machine. I want to be able to operate the entire system locally as if it was running in production. If I don't have that, I'm at a big disadvantage. And I will talk to my managers and say, I need this because this is a requirement of my ability to do work quickly and efficiently. So I should be able to run an interactive debugger in a Docker container at any point in time. If I don't have that, or if in the Docker container there is a coroutine or something that I just can't work around, an alternative is going to be a tool like New Relic or Sentry or Datadog to capture state and capture the transitions between states. It's a really good intermediate choice between logging and interactive debugging. I can also use profilers and other observability tools to quickly isolate and visualize the problems in real time. So there are tools out there that's beyond the scope of this presentation, but be aware if I can't use my interactive debugger for whatever reason, either solve that problem so that I can use the interactive debugger, like make sure I can run everything in a Docker container, or use one of these alternative tools, and then you have to investigate which tool is going to be best for you. Your senior engineer or someone on your staff can probably guide you in the right direction if you do run into that problem. One of the senior directors in my organization at Adobe made the comment to all of us, who were about 300 people on the call, said, if you can't run the system in Docker on your local machine, find out why and make sure you can. It is almost impossible to be efficient in time and quality without the ability to run the entire subsystem or whatever which you're working on locally in order to replicate the environment as much as you possibly can. So that was an interesting point coming from a senior director. And I happen to agree. And I've certainly changed my attitude now. If I can't get the system to run locally, I'm going to make inquiries as to why that doesn't happen. I'm going to solve that problem first, so that I'm not spinning my wheels trying to log into a system, in the cloud somewhere, trying to figure out what's going on. When do you use the debugger? Well, when you have access to it, it's a great choice as a first tool. So here's the irony. Most people go to print statements as their first selection. I'm saying go to the interactive debugger as your first selection. When logging is too wide a net, when you don't need the huge logs of data that logging provides, when you need to follow the process step by step and inspect the changing state of objects. So I can set breakpoints at different places in my code and execute and stop at each breakpoint. Breakpoint, stop, take a look at the objects, look at the data, what's going on at this particular frozen point in time. Hit continue, it'll execute the program to the next breakpoint, do the same, analyze the objects, analyze the state, analyze all the data, and keep stepping through the system. You can even step line by line. You can even go up and down the stack frame if you need to inspect data and objects in the stack frame. As you get more advanced with the debugger, it's an extremely powerful tool. When print statements are too static and you need to perform further analysis during operation. So print statement, print the contents of an object, that may not be enough. I may need to look at the contents of an object and the state of its instance and the state of its caller, and then maybe continue in code to see the state of its consumer, etc. And of course, when you need to observe, inspect, and analyze data up and down the call stack, not just in my immediate stack frame, but up and down the entire system. PDB is the Python debugger in Python. JDB is Java. PDB was actually based on JDB, and JDB was based on GDB, the new debugger. Both the VS Code and IntelliJ have built-in debuggers for various languages. I encourage you to research them and get into them. Very, very valuable. All right, a live example. Do we have time? We have about 10 minutes, 12 minutes left. I'd like to stop here for Q&A and answer any questions or address any comments that anyone has while I take a look at, see if we have time to do a quick debugging example.
Yeah, I believe we do have time for debugging example. You're
Okay.
right. We have like 10 to 15 minutes to go. So
All right, let me stop sharing and I will share my VS Code if I can get back to my screen here. Bear with me. I am going to now share my VS Code panel. Okay. This is an extremely simple example. Again, in a future, by the way, can everyone see this or do you need the size to be made larger?
It's good for me.
Look good? Okay. So this is a very old program. I use this particular package called Diceware Passphrase. I use it for a variety of different trainings. I would like to use a different system for debugging. I have a huge open source package I didn't write. It's written in Java that I'm going to use for debugging 200 for the next level of debugging training that will be a lot more complicated than this. Let's take a look at what I'm dealing with. I'm dealing with a Python program called getPassPhrase. Let's look at the help. Okay, it's gives me some information. Let's just, in the interest of time, let's generate a passphrase. All right, so let's just call it getPassPhrase with the defaults. And hey, look, a bunch of passphrases. Okay, it's just going to output some random passphrases. All right, this is too big. So let's take a look at the number of words. Let's just take 3 words. Okay. Oop. Whoops. See, I've screwed up. -W3. Let's look at 3 words. Great. So it's giving me a bunch of passphrases of 3 words, but let's shorten it up even a little bit more. Okay. Let's go get passphrase with 3 words and only 5 passphrases. Hey, pretty good. Well, let's keep looking at this thing because someone's complaining it's a bug. They're saying it doesn't work. Well, it doesn't help me along. I don't know what's going on. So let's just execute different use cases as if we were in QA, and let's try no dice instead of using. So instead of using the Diceware version, which gives me a normal distribution, let's execute with no dice, which executes a uniform distribution, which is a flat probability instead of a normal probability from a list of lots of words. And there's the problem. Boom. Great. We have an error. That's exactly what we want to go take a look at. So let's divide the problem domain. Let's look at the source code. Let's see, let's look at the traceback. Okay. Get password, no dice. Go to the word getter, and the word getter on line 105, system random choice, no dice word list. Let's go. And now, line 347, can't choose from an empty sequence. So let's go to line 347. Let's start, I'm going to divide the problem domain. Let's just go to line 347 and take a look at, there's a line 347. Oh, random PY. Well, that explains it. I don't care. So the problem is actually being raised by my randomizer. Cannot choose from an empty sequence. Why is the sequence empty? So let's go take a look at line 105. So I've divided my problem domain. This is in the software package. That's probably too deep. Let's divide it. Let's go back up a step. So 105. Okay, 105. System rand choice, no dice word list. Okay, interesting. Let's go look at the definition of no dice word list. Is it going to take me there? I'm failing my, all right, I'm failing my VS Code. So no dice word list is empty. All right, well, that's good. It starts empty. So let's now go back to line 105. And let's do this. Let's go put a breakpoint. So it's telling me that this is empty. I have no idea. So let's just, I can set a breakpoint, or I can import PDB and PDB set trace. How do I know this? I've been using this for a long time. Breakpoint was introduced in Python 3.10, I think. The old school was import PDB and PDB set trace. But either way, I'm going to now break the program at line 105. And hey, line 105. So now in the Python documentation, it tells me all the different commands that I can use in PDB. We're going to run out of time to get there, but I encourage you to go to the Python or documentation, look up the documentation for PDB, and you can see what the list of debugger commands are. W is where. I want to see where I am. I am exactly where I expect to be, line 106, right before the execution of this line. Now let's look at the contents of no dice word list. Okay, copy that, paste it right in. No dice word list is empty. That's a problem. So we need to figure out why no dice word list is empty. Oh dear. Okay, so let's go find other occurrences of no dice word list. Here it is. So let's go add a breakpoint here. And let's add a breakpoint here. Now, if anyone sees the problem, don't say anything. Okay, I'm going to quit my debugger. I'm going to launch it again. So where am I? I'm at line 70. That's right about here. Okay, so I'm just about to execute this open the Word file. Okay. Let's continue. I'm going to hit C to continue. I could hit step to step into the next lines, but I don't need that right now. I just want to see what happens at line 73. So I'm going to continue, and I expect this to break at line 73. And it did. So let's look at words. Great, there's a whole bunch of words. Interesting. So what's the problem? So let's step. This is going to take me forever. So let's put another breakpoint in here. Okay, I'm going to quit again. I'm going to run. There it is. Let's continue. We've already done this. Let's verify words. Words has data. Let's continue again. There's my breakpoint, and let's look at no dice word list. Oops. And it's got lots of data in it. Well, that's interesting. What's going on? Somewhere we have a problem. So I'm going to take a look at this, because clearly when I create no dice word list, it's being populated. Look at this, line 69. How do I get to, at the point of my error at line 105, no dice word list? Where's that coming from? It's not passed in to my function. Oh, it's a global. Ooh, I got you.
There's a question. There's a question.
Oh, there is?
Go ahead.
Sorry, I can't see the question. Please, go ahead.
Yeah, I just was about to say that the global is missing.
The global is missing. Well, it's right there.
I mean, in that.
Oh, in
the
line
next-
105.
Yeah, here.
I don't think it needs to be here, because when I reference it, that's a good hypothesis. So let's keep that in our pocket. I'm not sure that's correct. I think it's an excellent theory. So this is great. So we now have a theory to go test scientifically. The theory is that no dice word list doesn't exist in that before line 105. So keep that in mind, because we're going to prove or disprove that. This is another good case of skill for debugging. Come up with a theory and then prove or disprove the theory. So here's the global definition. I see the problem. Does anyone see the problem? Nope, nobody? Okay. So do I have time? Yeah, I can go over too. So let's do this. Let's test the theory. Wait. And I'm going to go back to line 105. Okay. And I'm going to change this breakpoint. I'm going to say global. I'm going to prove or disprove this theory. No dice word list. And I'm going to run it again. All right. I have some breakpoints in here. I'm just going to skip them. All right. Continue. continue, continue. Whoop, still get it, still not working. So our theory was we're missing a global in this function. We added the global, but we're still running a problem that this is still here. Let's do this. Let's breakpoint. Let's go take a look at the value of, whoops, this needs to be here. Let's take a look at the value of node ice word list, and let's take a look at, so I want to break at line 109. All right, I'm not at line 109. Still not there, still not there. There we go. Let's go look at the value of node ice word list. We have a question? Oh, someone grabbed the screen. Can you see my screen? Because it looks like someone took the screen away from me.
It just
I
unpinned.
can see it. Yeah.
Oh, yes, we can see it.
Okay. So node ice word list is still empty. So the theory that we're missing the global in this function, great theory, we've just disproved it. Excellent scientific work. And I'm not joking. This is exactly what you want to do, is it's like, I think this is the problem. Let's prove or disprove it. We've just disproved it. Super, that's extremely valuable. Oops, typo. So let me quit my debugging and let me go back to, I'm going to get rid of this breakpoint. Actually, no, I'm going to get rid of that breakpoint. And I'm going to back to 105. What happened here? It's interesting. Okay. Let us go back to my breakpoints. Open Word file, node ice word list. Let's copy that. And what's the value of node ice words list? Not defined. Okay, now I really know where the problem is. Does anybody else see it? In the interest of time, this is misspelled. So the value of this at the time, it's not defined.
Words.
Words. Let's get rid of that. Let's get rid of our breakpoints.
No,
And
there's
let's
the hand. Seriously.
Okay. I'm going to see if I can find my other global in here. There it is. I don't need
Is
this.
this the hand or just a misclick?
Is this what?
I see the hand, but the person is silent. So I'm asking whether there's a misclick.
Oh, someone have a question? Yeah.
Yeah, I misclicked. I apologize for that.
Not a problem.
So now I think I've corrected my error at line 90. Got rid of the S, misspelling, and there it is. It works. That was the problem. So using PDB, the interactive debugger, we were able to break down the problem domain. You'll notice what I did not do. I did not just start reading the code. I did not start to try to analyze in my head what was going on. I started with breakpoints. The breakpoint I started with arbitrarily was the point of the error, which was here. That's where we were bombing, because this was an empty iterable, and this method of the random package didn't work. So we started a breakpoint around node ice word list. I was expecting this to have data at line 104. It didn't. So we went and we set more breakpoints at the place that that data was being created. We put a breakpoint after this command. We started to break it down until we got to a breakpoint at this command to evaluate the state of what was a typo. The state of this was not defined. Bang, I've discovered my problem. The other thing we did was we had a theory that the problem was a missing global. So which is, again, that's exactly the process we want to go. I think the problem is we're missing a global. So we added the global at this here at before line 104, and we tested again to prove or disprove my theory. One of the major challenges I have met with some of the less experienced engineers is they conflate a theory with a solution. They say, oh, I know the problem. Missing a global, pull request, submit it for approval. Timeout. You've missed a whole step. You've come to a conclusion before you've had the data to support the conclusion. So the pull request gets kicked back. The developer is frustrated. I don't know, that was the right answer. So if you think you have the answer, change it from a conclusion, right, to a theory. Sherlock Holmes. I mean, this is classic. Prove or disprove your theory. 100% of the time, you're going to be right. You've either proved it's correct, and there you go. There's your pull request. You've solved the problem. Or you're going to prove it was not correct, and you can now move on to the next theory. Super important step to take, and it's one that I find a consistent challenge with less experienced engineers, even at Adobe. I mean, we used to see this at Global. Someone's like, "Oh, I know the problem." This pull request fails, comes back. I've now wasted, how much time of 1 or 2 or 3 different developers. So, science, hypothesis, proof, disproof. So that was another great step. I want to thank whoever. I'm sorry, I don't recall who raised their hand to suggest that theory. Thank you for that, because that was absolutely superb. We were able to demonstrate how do you make an analysis and then use these tools and these questions. What do I think? What is the code doing? How do I know it's doing it? How do I know it's doing it? That's the proof or disproof of the theory. So there you go, craft of debugging. Any final questions? And we're a little bit over time, so I thank you for your patience.
Thank you, Jason. So, guys, whoever has any questions, this is the right time to ask them. Okay, Dima, the hero of today's speech.
Yes. Thank you, Dmitro.
Yeah. Number one
thanks.
after Jason.
Thank you, Jason. So the question is, once I found this typo, is it like good thing to suggest or to cover it with the unit tests in order to prevent this bug?
Yeah, I
in the
mean,
future?
I would say yes, for sure. It's up to your organization and the standards of your group. Most teams have unit tests. Most open source packages have unit tests. So personally speaking, yep, I would do that. That particular repo is a toy repository. There's no unit tests in there. But in a real code repository, there would be unit tests. Yes, I would expect so.
Thanks.
And if one was missing, to your point, yeah, go ahead and write one. Make sure that everything operates as expected when you run the unit tests. Unit tests, by the way, are a great point to start with a debugging session. Someone says something's broken, run the unit tests and see what's going on. You may have a missing unit test. The unit test coverage may not be appropriate, or you may find the problem while you run the unit tests as well. So you have some different possible outcomes from a unit test suite.
Yep.
Anybody else?
Okay,
Roman.
go ahead, Roman.
Thank you for your speech. It was very interesting. I have a question: how to better approach bugs that come up under a high load on the database or high load on the application?
I'm not sure I understand the question. How do I handle bugs that occur?
Yes,
in a
no,
data?
I mean, when I test it locally, it doesn't happen. But it happens in production when the application is under high load, or components which are connected to the application, for example,
Great
database under high load.
So this is a great example of dividing the problem domain. So we have the whole problem domain is a production system that has a large scale of data and or a large scale of load. So we divide, right there we divide 2 problems. One is data. So we want to test, locally test with either a subset or the complete set of data from production. And then the second division of that is going to be load. We would need to simulate load. Now, if you can't simulate load, this is where using some sort of logging tool would have an advantage. Again, I want to reiterate, divide the problem. So one problem is database. There's something in the database that's causing a problem. The second division, the other part of the division is under load based on your description. So I'm immediately going to divide into two sections and test one at a time. Let's start with data. We have some options to us. We can capture the whole database and load it into our laptop in a Docker instance and test locally with a debugger and with other tools. If that's not possible because of size or security or whatnot, we can copy it to an integration environment and simulate the entire production in our integration environment. At that point, use logging. If you can't use an interactive debugger in an integration environment, that's the first choice. Just start looking at the data as it's being pushed through the process. Again, dividing the problem domain. So you have the database. Who's the first handler? Your database abstraction layer. Divide that. Then divide the next API consumer of the database abstraction layer, etc. Keep dividing, testing each section. If you have a theory as to what's going on, to prove or disprove the theory. Use the different steps we took today to continue to use these tools in that environment. If you can't get an interactive debugger and you can't push code, like to do print statements, use logging. Add logging statements, or if you can't do that, use Sentry or use Datadog, use some sort of inspection tool. At some point, if you're going to test data in a database, you're going to need to push code to add logging or do print state, do something to inspect the state of data at different points in the system to try to reproduce the bug. For testing scale, you would need, this is trickier. There's a couple of things you could do in that. If you think the bug is being created by a load in the system, you have some options here. You want to prove or disprove that hypothesis that it's a load, it's being created by load. Now, if it's an out of memory error in Java, it's probably load that you can solve in your code base. So in that case, you'll want to use a variety of tools that are available to you that fall under the logging domain. Sentry, APerf, which is a Java performance analysis tool. It's an asynchronous performance analysis tool. There's some Java profilers, inspectors. You'll want to use logging as a tool to figure out what's going on. Inspect existing logs. Is it an OOM? Well, there you go. Now you want to start tracing back to that OOM. What are the conditions that create that bug? So it's an excellent question. And I think the fundamentals apply. One is divide the problem domain as much as you can. Use these three, figure out which of the three different tools is most appropriate for your particular debugging session. If you have a theory, fantastic, write it down and prove or disprove the theory. And keep going, keep dividing. We do run into problems like that pretty consistently at Adobe, obviously, because the scale of Adobe is so large. And a lot of our Java is, it's been around for a long time. So we use profilers, we use Sentry, we keep running metrics, we use Prometheus, all these companies do this. I can't give out so much information, but we have lots of observability data that we can analyze to determine the state of a system at any given point in time at the point of failure. At that point, it's up to the developer. You can run it locally and use a debugger, logging on the system, etc. And I leave that up to you, Roman, to figure out how you want to proceed in that case. But again, divide the problem domain, ask those three questions, and use those three tools.
All right.
Thank
so
you.
we have, thank you for your question. And we have 3 questions more in the chat. I can read it out loud. And
Okay.
so basically, what tools do you recommend for detecting memory leaks?
Aha. Depends on the software. What language are we talking about? C++, Java.
Okay, so Java.
Java.
I think this question is more about Java.
Yeah. Boy. Caveat emptor, I am not a very experienced Java programmer. I can say that we use, what is the tooling? We use APERF, which is from Amazon. APERF, which stands for asynchronous performance. We do a lot of observability, so we will analyze the data from our observability logging and measure the growth of memory, the consumption of memory against the process that was running at the time, and then go analyze that process. I don't have a very good answer for you because this is actually a very it's require an experienced Java developer, which I am not. What I would do is get on the web and look for, if you're using Corretto, I would look for Amazon's recommendations for performance analysis and testing for memory leaks. In my IDE, especially IntelliJ, I would run the program in Docker and I would examine memory consumption and tie it back to a particular process or method or class. So yeah, there's a variety of tools you can use both upstream in the cloud and also locally in your Docker containers. I would look up to see what those were. How do you prevent memory corruptions in applications? That's a whole subject unto itself. As you're programming, especially in C++ or Java, use your internal profilers in your development tools. Use your profiling tools in your IDE, especially in Android and especially in Java and C++. Use Rust if you can get away with using Rust instead of Java. It's not always requirements. How do you recommend managing dependencies on external systems to minimize the occurrence of errors, and how can we effectively debug issues caused by external services? Again, divide the problem domain. Divide the external service from your local service, right? Test consumption of the data from your external service. If you can, isolate the code from the external service and identify any problems in the external services. If you don't have access to their code or whatever, it's an API from some third-party system, document the input and output and then go talk to them. So that would be more of a management issue than an actual data analysis issue. So managing the dependency on external systems, that's a design issue, I think, and it's a bit out of the scope of debugging, but how would you debug an error in an API to a third-party dependency? The same way you debug anything else. Divide the problem to external, internal, divide into the request API, if possible, what they're returning back. Break it down as much as possible to see that what you're asking for is valid and what they're returning is valid. And if either of those is a problem, if you can fix it on your side, you have the answer. If you can't, you'll need to talk to upstream. Okay. Yeah, it's a design issue, and I think it's a design issue that we all deal with. As you can see from the CrowdStrike problem of a couple of weeks ago, the entire world was dependent on an external system and they crashed hard. How do you mitigate that? That's an architectural choice that has to be made. I think the best way to manage that is to have as many safety protocols and programming on my side, whatever I can control. So if there's an exception in an RPC to and from an external source, I log it, I log all the data, I log the stack trace, I make sure that my post-mortem analysis has as much data as humanly possible. You can do this in systems that have high observability, using Honeycomb, using Sentry, using Datadog, using Cilium, whatever. Gather as much information as possible and then analyze it, see what's going on. Memory management in Java is always a challenge. Same with C++. This gets into just being better and learning more about memory management in Java, but how to debug it, observability, logging, you want to be able to relate the memory consumption with a particular running process. That's the first step. Divide the problem domain into where's the memory being consumed and what's the consumer. And then take that process that's consuming the memory and analyze it and debug it. And if you don't know where to start, come up with a theory and then try to prove or disprove the theory. If you need to, get a very experienced Java programmer to help you, which is also a good choice. Great
Yeah.
question. Very, very good questions.
All right. Looks like we run out of questions.
Fantastic. And we've run out of time.
Oh, no. We have
One more.
one hand. One more. Go ahead.
Hello, thank you for your presentation. It's very interesting and useful. I have a next question. If our application have to work with third-party services, and some of our customers sometimes faced with floating bugs, which approaches except login may be working in this situation?
Could you, Valerie, could you repeat the question for me, please?
If our application is working with third-party services, and some of our customers sometimes faced with floating bugs, which approach may be working?
Floating bugs. I mean,
floating bugs.
What's floating box? Sorry.
A bug that may appear and then disappear and then.
Oh, an intermittent bug. Yeah.
Yeah, exactly.
In those cases, logging would be the best way to go. Just throw some logging up there, capture as much state as possible. Make sure that if there is a bug, you should know where the bug is occurring. If you don't, you'll have to really log like crazy. If you know where the bug is occurring, let's say it's an exception or a failure in a try-catch loop, log as much data and state as possible at the physical location of the source code where you think the problem is happening. Come up with 2 or 3 theories of what you think the causes are. Add lots of logging to prove or disprove the theory. If you have access to observability tools like Sentry and other things that can capture the state and the changing state of the system, use that as well. But in a case where it's an intermittent bug, one theory would be it's data-driven. So prove or disprove that it's data-driven. Capture the data signatures, the data itself, and the state of the data as it's going through the system. So you can correlate that to the location of the error. Use Sentry to measure and capture the flow state of the software, what functions and what methods are being called in what sequence. Is there a method that should not be being called? Is there a method that should be being called? So what you want to do is try to break down the problem as small as you can, because if you don't know where the bug is, it's a bit challenging. What you can do is break down the system into different sections and apply logging to each of the different sections. So when the problem does happen, you have a timestamp. You can go to your logs, look at the time range of where the bug happened, and analyze the state of the system, analyze the state of the data, and analyze the process flow, what was running at the time of the problem, and try to isolate and break it down from there. That would be a multi-step investigation, because the first thing you need to do is capture the conditions so it's reproducible. So step 1, reproduce the problem in a consistent manner. Once you're able to do that, you can start to apply these other steps we talked about and the different tools we talked about today. But logging is definitely the best way to start there. You need a whole bunch of data to see what the heck's going on in there.
Yeah, exactly. But the consistency is the problem of this type of bugs, because, well,
yep,
no one knows when it happens again and again. But yeah, I agree.
Yeah, log it. I mean, so the first step is, how do I know it's doing it? I don't know it's doing it. So what do I want the code to do? Run without bugs. What's the code doing? Every so often, under some strange unknown condition, it fails. How do I know it's failing with an unknown condition? Well, obviously we see at observability, we're watching it happen. So the step 1 is, I need to know what's causing this thing. So what is the condition that's causing the problem in my system? That right there, logging. You're just going to need to do a wide net of logging to try to identify the source. It does help to have some theories ahead of time so you can prove or disprove them. It gives you a way to sort of narrow down the problem scope. I would say, well, it's my theory would be data. Maybe it's data driven. So let's capture as much data as possible and take a look at the state of data at the time we have a problem. Let's look at maybe the next theory is the wrong method is being called. All right, I don't know. I mean, I'm guessing here. These are good guesses, so let's prove or disprove these things. So yeah, those are a challenge. They can be time consuming, but logging and observability is your friend in that case.
Yep. All right, guys, thank you for your questions. I really appreciate your involvement and your comments and your contribution, because actually this is what this is the reason why we're all here. We're here not only just to hear what Jason says, but we're also here to discuss and to get involved and to come up with some new ideas. And basically, thank you guys for your involvement and for your questions. And Jason, once again, thank you for your time. It was our truly pleasure to have you here, and thank you for your valuable information and presentation and your techniques that you demonstrated to us today.
You're very welcome. It's my pleasure. I hope this is valuable to everybody for sure.
Inevitably, yes, undoubtedly.
Thank you, Jason. Thank you, Jason, for spending this morning with us.
No, it's my pleasure. It's great to see everybody.
All right.
Hope to see you soon.
Yeah.
Bye.
Thank you. And
Cheers. Thanks, everyone.
yeah.
Thank
Cheers.
you.